I'm calling this one Don't Sand Your Pinch Rollers. I know that that's conventional instruction here on YouTube University, but I've said a number of times that it's really not possible to hand sand a circle. The problem with this one, I mean, obviously there's the radial run out, but even a bigger problem on this roller is the axial run out. It's waddling back and forth like a duck and causing excessive phase shift in the upper high frequencies. So I had to turn a mandrel for this, or an arbor, to be able to precision grind it. The axle on this is about 60 thousandths, and that's pretty small. And to be able to screw it down, I would have had to have something smaller than a 0090 tap and drill. So the 0090 I think is about 48 thousandths. That would leave me with a wall thickness of about 6 thousandths. And just by comparison, that's along the lines of a thick sheet of printer paper. So I turned the shaft a little bit longer and thought I could either make a sleeve for it, or in this case what I ended up doing was doping it with some beeswax. So let me get you guys off to the side so that I can see what I'm doing. Now there's not a lot of pressure in grinding, or there shouldn't be. I mean, there can be, but it usually doesn't end up too well. So I think this will hold just fine. If it doesn't, I'll make a sleeve for it. Okay, so I'm just going to chalk that up and then remove the chalk. I'll go just about as slowly as I can go on this. These are newer machines, and I don't generally have to, well, I've never had to actually grind a pinch roller off this model. Like I say, they're newer, and they're usually in very good condition, and this one was in good condition, or so I thought. It felt good. It cleaned up beautifully. I, brushed it, scrubbed it with soap and water, and it did really well. I mean, it looked really good. Of course, I didn't look at it like this. I actually discovered it when I was running frequency sweeps, and on the upper high frequencies, I saw this phase shift. This shouldn't be happening. Oscillation, I shouldn't say shift, it was just an oscillation, but it's more than what should be. And I couldn't really tell exactly where it started because the frequency counter on the scope couldn't keep up with the sweep. But at any rate, the higher the pitch got, the worse the phase waddle got. I don't know what led me to look at the pinch roller, but that's where I ended up looking. Okay, so all I'm doing here is just taking off the chalk. I'm not reducing the diameter very much. I know it probably doesn't look like there's much of a crown in that, but there is, and it is the correct crown. And I've shown that on past videos. Speed through it. Okay, I'm just going to chalk it up again and just barely kiss it, just to make sure I've got it round. Okay, that should do it. We'll do a before and after. I'd say that's a little bit better. There's There's still a tiny drop of wear in the hub there, but the axial runout's gone now, and it's obviously it's round, circular, I should say. Okay, continuing on. This is the head bracket. You can see how nice and clean that is. I've got the record head lapped, the repro head polished, and the erase head lapped. Okay, there's the bracket all cleaned up, and there's what I got off that bracket. Okay, this is the product I use to coat these. It's a graphene impregnated ceramic coat. I'm coating all the decks that I work on now, including all my own. Of course, this was to help eliminate the breakdown of the ferrite on those erase heads that cause the high frequency erasure, but I also find it to be just a great product because it makes cleaning the heads so much faster, and things just don't stick to them. Very simple. Wipe it on, wipe it off, and then let it dry up for 24 hours, and then polish it off. And here's the product here, if I can get it in focus. At some point, I mean, this is enough to do several lifetimes worth, so at some point I planned on just dividing this up into small bottles and maybe offering it for sale. But there's the product. And this is their marine grade. The marine grade one has the graphene. I've done several videos on this. Maybe I can put a card up here. And I'll do 3 coats of this before I return it to the owner. They do say 1 coat's sufficient. I've done a lot of coatings in my life, and I've never found fewer than 3 coats really to do the job. So that's it. Let it dry for 24 hours and then buff it off. Okay, picking up where I left off on the previous video. Get the gear train assembled. This will be a little tiny bit of lubricant on the axles and the hubs. Doesn't need a whole lot. This is the moly coat that is plastic safe. No lubricant needed on the inside of the cam gear. It doesn't engage anything on this model. So just the hub and the, I guess, outboard side of the cam. And that's it. That should rotate freely. I kind of want to make the point here, there are some aftermarket cam gears available, and the ones that have been sent to me all had a bore that was interference fit, and it shouldn't be. It should be rotating freely for a lot of reasons. Obviously, to reduce stress on the motor, but also to prevent it from cracking. So if you have one of those gears and you've put it in, you might want to take it back out and just, I have a reamer that's the right size, but drills can also do the job. It should rotate just like that, just very freely. I've said before, I don't lubricate these gears, the gear teeth. It's not necessary. This thing doesn't rotate fast. It's not under a lot of pressure. It doesn't have, it doesn't rotate a lot. You notice they never lubricate the real motor gears, and those rotate all the time. So if there was one to be lubricated, it would be that one, and the factory doesn't lubricate those. I've tried it before, trying to quiet this transport down. It makes no difference at all. I think the designers thought the sound was maybe, futuristic and high-tech, whatever. I don't. I think it's irritating. I'll take a silent mechanism with a control belt that needs to be changed once every 20 years, anytime. Okay, that's all it needs. This will just, it will kind of find its own happy spot. You'll know when it's right. I do use either the blue or the purple thread locker on most screws now, just that much, tiny bit. This won't prevent disassembly, it just kind of helps out a little bit. Okay, that's nice and free. Finish that part up. I've talked about this before too. Tascam chose to use way too thin a gauge wire on everything, basically. And it won't take much for these to come apart. That yellow one I actually had to solder already, but that's all it takes. And it would be a terrible thing to ship this thing back to the owner and have that break off during shipping. So I just like to get a fresh connection on all these now. Both motors, and then on the Mark II, generally all the micro switches will also have bad connections, or failing connections, I should say. Come on, get out of there. There, finally. And get all that garbage lead-free solder out of there too. I'm just going to cut those off and get a fresh end. I'm going to flux them, tin them. Leave about a wire gauge diameter of unsoldered, and then try to clean any flux from under the insulation. Same thing on the real motor. You can see that doesn't have a lot of life left in it. Now speed through this. Just want to get all that off there. I want a clean job on this. That's also why I don't wrap the lead around a dozen times and twist it. It just doesn't need all that. If the solder doesn't hold that little hook, then you got more problems than that. Okay, same exact procedure. Okay, good enough. Okay, so Jeremy, this is for you. We were talking about this earlier, and I wanted to show you the insert on this. There's the little kit. This is the part I wanted to show you. The little data sheet that they include. If you'd like, I'll take a picture of this and send it to you. I don't know how well this is going to focus. Maybe you can see it, I don't know. So those are the lubricants for the ball bearings on this. And I'll use two different ones. Okay, so all the metal to metal gets the Lubriplate 3000. Been very happy with that product. It has a lot of stiction. You don't need to use a lot of it. And then this will be that damping grease for the head stack assembly brackets. I just want to fill that channel. There's no reason to have grease anywhere else. And just touch what's basically the bearing race right there. Okay, and this hold down will get the heavier of the two. And again, just filling the pocket. There's no reason to have grease anywhere other than that. I've shown this in a lot of other videos, but it doesn't hurt to show it again. I remember in a past video when I went through this exact procedure, and I had some, well, I ended up finding a little piece of debris. I could tell that this wasn't operating smoothly. So I took it all back apart, and there was the tiniest bit of debris. Of course, don't know how it got there, but it was there, and it was preventing that from operating smoothly. And so I always like to check that. Okay, just a little bit right there. And this will kind of show you how much stiction that louver plate has. Okay, now that all that's back together, you can put the brake spring back on. Just want to make sure that's clean. I did reverse those brake pads. Okay, I like all that. Get the height gauge in and see how we're doing there. Of course, I've already adjusted it. I was just going to show you how I do this. I put a piece of white paper behind the heads, shine the light on the paper, and then it very clearly shows the gap between the gauge and the head. It works really well. Okay, so I've got those aligned pretty well. And I'm in good shape on the guide. Check the race head, and of course I did check against the height lines, and it was right in the middle. Now on the race head here, the outer guide is touching the gauge, and the head is canted downward. And this isn't unusual. I see this a lot on these encased plastic housings. They shrink over time, and they will move. They'll sometimes inboard, sometimes outboard. In this case, it moved inboard or rotated down. And you can see right there on that bottom mount where I just had to just barely touch that a little bit and flatten that out. And I'm prepared to add another shim to it, but I didn't need to because it just rotated the head back parallel to the tape, and that was also enough to give clearance to the guide. but sometimes have to add shims on these, and that's not a big deal. Sorry, all you can see is my hands there, but okay, so that's it, and the head is now parallel to the tape as well. That happens a lot on these plastic housings, just something that has to be dealt with. Check the roller pressure. That's just a little regrinding I did so I can grab the axle or the top of the housing. Now this calls for a 380 to 480 grams. I always like to run these on the light side, especially now their tapes are a little bit older and more brittle. Okay, looks like I've got close to 4. Let's see. Okay, looks like I've got about 410 there, 420, 420. That's not bad. I think I'll leave it there. In the end, I go back and take it back down to about 380, the minimum, just to try and get the wow and flutter numbers a little bit better. Okay, I just wanted to show you this shield. I found oil, some kind of oil, all over this transport. Both sides of this were soaked in oil. I have no idea. It just makes no sense at all. You know, sometimes it's like the old deoxit. You see it around a lot of pots and things like that where people have, you know, I'm making air quotes here, you know, cleaned the pots, and there's a film of deoxit all over the all over the whole area. This is kind of like that same film. I don't know. But anyway, I won't put it back like that. Okay, so it's the next day here. I'm just going to polish that off. I also like to do the guides. And that's it. That can be done once a year, once every 2 years, whatever, depending on how much it's used. Degauss the whole tape path. I'm obviously fast forwarding here. Just double check it. I've done a lot of work in here. I've had a lot of magnetic tools in here. Okay, I don't mind using my test tapes on that. Okay, Jared, I'm going to use your A&T tape for the wow and flutter test and to set the speed. I've got to try to find where that's at. Now that the door's back on, I'll also go back and tweak the azimuth, repro and record. And yeah, it is New Year's Eve here, and my neighbors like to start a little early. That's also the warning from the security cameras telling me something's going on. Okay, I've got to find where it's at on this tape. I'm not familiar with it. Yeah, you can see that little bit of oscillation in the waves. I have not discovered the pinch roller problem at this point. Okay, here we go, 3 kilohertz. Okay, so there are your results with your tape. I'm satisfied with that. We'll set the speed here. The speed trim pots on this model are behind the left rack gear bracket. Why? I don't know. Ask Tascam. Anyway, I know you're going to do all your own calibrations, and but I just want to return it to you the way I'm seeing it here, and of course using your tape, which is great. It's in agreement with my tapes. And then I'll get the pitch control vertical and dialed in 0 also. It doesn't hurt to run them back and forth a few times and make sure they're clean. Okay, so the rest of the calibration's up to you. And here's to wishing you all best of health and good cheer for 2026. Thank you all for watching.